It's far away from the Earth, it's far away from the Sun.
It's the first time we do anything like that. The environment is totally unknown.
It's not a planet. When I first heard the idea of Rosetta, I thought it would be extremely difficult.
We've never flown a spacecraft to a comet.
It's the first time anyone has actually attempted
To land on a comet, anchor its surface, collect samples.
That we arrive at the comet, we don't fly by. We stay there, we orbit it.
None of this has ever been done before. Rosetta travels a total distance of about 7 billion kilometers. Rosetta was launched in March of 2004, has flown past Earth 3 times, once past Mars, and then away from the Sun to the depth of the solar system, about 5 times further than the distance between Earth and the Sun. It is possible that the building blocks of life were brought to the primitive Earth aboard a comet, out there somewhere.
I started hearing about Rosetta in 1996. It was immediately, let's jump on it. It's an extremely challenging idea. Nevertheless, it never looked impossible to me. It's a matter of learning, it's a matter of getting the right accuracy, getting the right tools. And at that time, we had none of those, but we had time to prepare them.
Everybody, wherever you may be, welcome again to Kourou, the home of Ariane, for our live broadcast of Ariane Space Flight number 158. The launcher, as you see, is on the pad. The clock is ticking. The panels are green. What could be better? Sit back and enjoy it. 3, 2, 1, décollage.
On Earth, there is probably no surface exactly like that of a comet, which could turn out to be either much softer than new fallen snow or as hard as a sheet of ice. The snow here on Earth, all the water on Earth, might have come from comets. We think there are organic molecules in comets, and that comets from somewhere out there brought the basic building blocks of our life to the primitive Earth as well. That comets hold the key to the origin of life. Every single comet is of scientific interest, but Churyumov-Gerasimenko is one of the few on which the Philae lander can touch down. Philae is a lander that will separate from its parent spacecraft in 2014, land on the targeted cometary region, and carry out a complete measurement program.
Instead of bringing back the samples to Earth, we bring scientific instrumentation to the comet.
It is definitely interesting to see how complex it is for the team to calculate all the trajectories. Which path must be flown? How many maneuvers are needed to get somewhere?
The problem is that there's no rocket, there's no launch vehicle on the Earth that can actually deliver Rosetta on the same trajectory where the comet is. So we had to use some tricks where we actually transfer energy from a planet onto the spacecraft. To achieve this, we have used the gravity potential of the planets. The planet itself is dragging the spacecraft for a while. This small energy is a gigantic energy for a small body like the spacecraft, and then it's launching it away. So the spacecraft is launched away like in a slingshot where it's accelerated dramatically.
We were forced to go through twice the main asteroid belt.
Then the scientists thought that this would be a good idea to combine the exploration of a comet in detail with the chance to fly next to asteroids. We've used our rockets, which are on the spacecraft, to fly it such that we'll meet the asteroid exactly in the point we want tonight. In a few seconds we should start losing the signal. I think we have already lost the signal.
The spacecraft should point the antenna all on its own and then send the signal to ground.
There's nothing we can do in real time, so there wouldn't be any action that we have to take immediately to react, to save the spacecraft or to recover the signal. This would be impossible. We have telemetry right now from the spacecraft.
Congratulations.
It's absolutely nominal. What we can see was quite tense. Of course, you are looking forward to seeing the spacecraft coming back again, but this was the case, and then a large stream of images was downlinked from the spacecraft.
It's like Christmas.
It's the first time that a spacecraft has flown so far from the Sun using solar panels. Rosetta's solar generator is now only providing a small amount of electricity. It is primarily used to warm the probe enough so that the electronic equipment and scientific instruments are not damaged by the low temperatures.
We cannot operate the spacecraft anymore. Like now, we're so far away that the spacecraft has to be switched off. Spin it up, switch it off, and leave it there.
The hibernation of Rosetta is lasting 2.5 years till January 2014. I have a bottle of champagne from the launch of Rosetta in my cellar since 2004, and then maybe this is an occasion to open it if and when the spacecraft comes back.
For a spacecraft operator, not being in contact with the spacecraft is the worst thing that can happen.
Entering hibernation for Rosetta was a very strange feeling. I would have expected to have many problems after having flown this spacecraft for more than 8 years. You know that the spacecraft is existing, but you don't have contact every day with the spacecraft.
You work so many years on a project, of course, a lot of special relationships develop.
You can't help it. It's almost like a member of the family.
It's difficult to stay away. It's like with a child when it grows, and in the early years you are in full control, and then gradually you lose a bit the connection. It's still your responsibility. You feel a bit uneasy.
No other spacecraft went beyond 400 million kilometers from the Sun with solar arrays, so we have broken a record there, and we will hold it for a couple of years at least.
But now comes the part that's hardest to foresee.
On the 20th of January, the probe will wake up once again.
Then in November, we land.
I bet we'll be awfully nervous on that day.
Should I contact the ground station? Great, let's play your favorite hits. Should I contact the ground station? Great, let's play your favorite hits.